All right. So we're going to quickly go through a kind of a review over what we have done last time. And then we are going to go into member functions and privacy. We talked about dynamic memory allocation. I'm just going to bring the syntax up quickly and the slides that we had, which I can just run it from there. Let me just do that. Talking about dynamic memory allocation, very quickly I'm going to go through everything that we talked about, and then we're going to continue with what we have today. We said that every single time you create anything, any variable in your computer, the variables are statically allocated, which means they are actually placed inside your executable program. As your executable loads into memory, the variables are loaded, and as the variables go out, the executables go out. As the executables go out, the variables are gone with it. This is statically allocated memory, which means the bigger the variable you create, the bigger the executable get. In this case, we are having 5 integers. If you make that 5,000, your application is going to grow 4,995 integers bigger. So the way around it is to actually do it at runtime instead of compile time, which means we just create one pointer in our program, which is a pointer to whatever we want to create, only one pointer. And as the program is running, we request the operating system to give us some memory. And that memory is not within our executable anymore. It's in a shared memory that everybody uses. Yes? It really literally tells to the operating system, I want new 5 integers. So it allocates, it creates that memory. Oh, it creates that memory inside your inside the heap and passes its address back where you want to, where you have the pointer. So when you say new int 5, it means dynamically 5 integers will be allocated in memory. The address of beginning will be returned to you by new. Anything that is standing in front of new will grab that address, which in this case is A. Okay? So that was dynamically allocated memory. And we said that dynamic memory allocation syntax is pretty straightforward, which means there are certain rules and regulations that you have to follow to make sure that it's the least possible way to have dynamic memory leakage. The first thing is that whenever you create a pointer, you make sure that pointer is null, okay? And don't use it unless you actually allocate the memory, because if it's null, it doesn't point anywhere. Whenever you are doing you require, based on the logic of your program, to set to dynamically allocate memory, you call the new command, putting the amount of memory that you want in front of it and a pointer that is suitable for that. So if this type over here is the type that you want, data PTR should be of type pointer. Always stay within the size of your data. If you go out, it's not your memory anymore. Like a regular array, it's going to crash. And when you're done, make sure you delete it. And that's it. So after you delete, you make sure that you set that to null. So after you delete, make sure you set your data pointer to null. So in future, you can actually detect it is deleted or not. Going back quite quickly through the things you have to follow to make sure you don't have any problem. First thing first, always have the data and the size for it. Make sure that the data that you have before, as I mentioned before, you allocate anything, you make sure that before allocation, it is set to null if you're not using it. Any unused pointer should be set to null, and size hopefully set to 0. If not, that being null is a flag so that is sufficient for us to recognize that we don't have any memory. Again, stay within your size. Whenever you have a pointer that is pointing to somewhere, before you allocate new memory in it, you have to make sure that you delete the old one. If you do not delete the old one, then you'll be in trouble. You're going to have memory leak. So anytime that the data is set to a new value, the old data is lost and there's no way to be found. There's no way that you can retrieve that address. And there is no mechanism in C++ that does garbage collection and collect the memory. If you leave it, it's there until you reboot your computer. The correct state of as an unused memory, as we mentioned, is always null. And when you allocate, you have to make sure the size is exactly set to the size that you have so you can keep track of what is the size. And when you delete it, you have to delete it the way you created it. If you have created it as an array, you have to delete it as an array. If it's a single one, then you have to delete a single one without the square brackets. And after you are done with it, you have to make sure that you set it back to null to always be able to trace and track and see what happens. If by mistake, when you are deleting, you don't put the square brackets in front of a dynamic array that is allocated, that is deallocated, if you don't put the square brackets in front of it, only the first element is going to get deleted, and therefore you're going to have memory leak. Make sure you always delete the same way. Always test and examine your pointer to see if it's null or not, if something needs to be done before you delete it. I don't know if it's needed. If you don't need it, just delete it. But if you want to know if a pointer is pointing to something and it's being used, you have to make sure it is not null. And that's that. Then we talked about resizing memory. We said resizing memory is when we have a piece of memory already allocated and we want to change the size of that memory. And to do that, we have to do certain processes happening back to back. Number one, you have your pointer pointing to the data. Number two, when you are actually, number one, you have your data and you want to resize it. The very first step you need to do is to create a temporary pointer of the same type and allocate the required amount of memory that you want. That memory could be bigger or smaller. You want to resize it. It doesn't matter if it's bigger or smaller. You can truncate or you can expand. After doing that, you have to copy all the old data and bring it to the new one. Doing so, you are not losing the data that you have and you can actually resize. Now, if the new size is smaller than the old one, only the first few will be copied and the rest will be truncated, which probably that was the reason you were resizing, because you didn't need the memory after. Anyways, so after the resizing is done, you can actually delete the old data and be gone with it because you already have the copy. And after doing that, you have to make sure that the size is now updated because you have changed it, so it becomes the new size that you have. And finally, the last step that you need to take is to actually make the pointer that is supposed to point to data to point where the temporary data is pointing. And doing so essentially makes the memory bigger. Of course, it's not at the same place, but wherever new place you are, the values are copied and the memory is done bigger. And that's where we ended everything with dynamic memory allocation. We talked about dynamic memory allocation and syntax. We gave a few examples. Then I created an example for resizing memory, which was quite complicated. So I'm going to quickly go through it and explain what we have done over here and why it's done the way it's done, and I'm going to make it simpler. Okay? The reason that what we needed to do over here is that we have a piece of data. We have a memory, a pointer that is pointing to a piece of data. That is in cases 4 integers at line 36. And we have some value in it. Now I print it using the print function that I have. I'm going to print four elements of the array, which is fine. Now I want to expand it to 8, which means I want to make it bigger. So why I am passing the data and then I am returning it at the same time? That makes it a little confusing. The reason is that every single variable in C language is passed by value. We do not have any concept of passing by address. There is no such thing, neither in C nor in C++. Therefore, when I actually expand, let's say this is the data. If I did not return it, take a look at the code that we have. In here, I have followed the steps that we had. I am returning an integer pointer. Let's say integer pointer is not there. And I only have data over here that is supposed to get resized. So essentially what I have, this is the data. And this is the memory that it has. And it's pointing to it. So, oh, not that. As I was saying, this is the data. I have 4 integers over here, and I want to resize it. If I pass this data to another function out there, this is how the function is called. So the expand will create a pointer of its own, receiving the address of data in there. So what we have in expand is actually a secondary pointer, which means this is going to be the expands pointer. Let's go back up. Again, as I mentioned, take a colorful pen and go through it, and on the paper trace the execution, and you'll see what I mean. So now, when it's called, what happens is that this becomes the data. So essentially, this becomes the data. And this is main's data. I'm going to say data in main. Let's put it over here. So when the function is called, the content of this data will be copied into the data. If that's the case, then what we are going to see is that the data is going to point to here. And all the processes that's going to happen over here is going to happen to the data. So essentially means to the data argument. So let's walk through. So I'm going to have over here new data created. So this is new data. Then I'm going to say new data is the data. So what happens is essentially points to the same place that one is pointing, which is fine. Then it says if new size is bigger, so let's assume it's bigger, it actually creates a temp. So now a temp is created. And that temp points to a new size. So the new size that we have is bigger than the old size that we have. And this is temp. Now it copies everything from the data into the temp. Therefore, everything from here will be copied to here. And the rest remains empty. The next step would be deleting the data. So when the data is deleted, essentially this will be wiped out completely. This will be completely gone. Now, temp has the data that I had before, so there is nothing to worry about. Now I'm going to say new data will be temp, which essentially temp is going to go to the new data. So new data is going to point to the newly allocated memory. The problem over here would be, that all the stuff that are happening right now are happening essentially in variables that has nothing to do with main. It is at these two are in expand. This one is in expand. So after all this thing is done, when the function is returned, if I do not return the data that is actually allocated, when I come back to main, all these values that are in a square will be gone. So I'm going to have the data in main pointing to some garbage memory that is deleted. Therefore, it's wrong. It shouldn't happen. That is why I am returning the data so I can put it back in the main, and therefore main is going to point to the newly allocated memory. So that return statement does this last arrow, which essentially makes it possible. Now, all those things aside, how can we fix this to remove this complexity? There is one concept that you have to remember. We have something in C++ called references. Reference essentially means I can give new name to already existing things. We talked about pointers, and we said pointers, when you are writing integer asterisk together, they mean a pointer, and they are a type. Because they are a type, all I need to do is to make a type to that point, reference to that type, as I did for regular functions. We said if I have a function over here, void add1, and I create an integer reference pointer r over here, if I do r++, and I have another function that has integer I, and I say over here add 1 I, because the function call is as add 1 integer reference r set to I, what happens is that r becomes a new name for I, therefore the value of I will be changed. This r is not a new integer, it's an integer that belongs to the main. That's the concept of references. If that is the case, I can do the exact same thing to that function of mine. So, to make the function simpler, this is what I'm going to do. Instead of creating expand like that, I'm going to say it doesn't return anything, but instead, this is going to be reference of the data, which means this actually will be the data in main. This variable will become a new name for the data in main. Therefore, I do not need to do any kind of returning and setting and anything. All I need to do is to say the data is set to temp. And that's it. So all those complex stuff will be gone. Now, when the function is called here, that is removed. When the function is called over here, it will be integer pointer reference. The data will be equal to that. So essentially, this becomes a new name for data in main, and everything is done properly. So that's essentially the gist of dynamic memory allocation to the bone. Okay? And I'm going to give you more examples as we go through it, simpler examples and more examples. But please, again, as I ask you, take a pen and a paper, walk through this. And on the paper, draw the variables and do it. If you don't do it, you won't get it. It has to be done on the paper. Okay? All right. So that's that. So that was kind of a review. And if I run this, you will see that it's going to actually expand the data if there's no mistake. And there we go. And you can always run Valgrind and see if it works or not. That's that. Now, moving on. So this is 01 DMA. Whenever I say DMA, it means dynamic memory allocation. DMA resizing. Continued. Now, completely change of concept. We're going to go to something else. Okay? We are going to talk about encapsulation. And then at the end of our encapsulation session, I'm going to go back to dynamic memory allocation and give you another example that is simpler. So let's say I want to create a structure that holds information about an assessment. If I want to do that, how do I create it? I create a structure assessment, and an assessment has a name and it has a mark. Okay? That's all we need to know about an assessment. So I'm going to say character. I can call it title. From now on, any variable inside a class or a structure, you should start it with an M underline. Pardon me? M underline. I'll show it to you. So I'm going to write it over here, M underline title. And say it's 128 characters, which means 127 with a null. Okay? And then I'm going to have another character, an integer over here, and I'm going to call it mark. So an assessment has a title and a mark. Are we okay with this? All right. Now, if I want to set this assessment to something, what do I do? With all the references and stuff that I learned, I can create functions over here to do that for me. So I can actually create something like void set that receives an assessment reference A. And I can have another one called, say, print that receives a constant, obviously, assessment reference A to print it. So that becomes an assessment that I can set it and I can print it to see what I have inside. Simple and straightforward. So to create this, I'm going to actually go over here and I'm going to say create a definition assessment.cpp and have it in 2 windows. Okay. So that's that one. So if I want to set an assessment, what do? First of all, I need string header file. Actually, we had some CSTR that we used in the workshop, right? I'll bring that one so I don't have to use it. Let me see, in the workshop 1. Yeah, we have CSTR. I'll bring that one. Copy. Right click. If you want to add, remember, if you want to add different types of files to a solution, right click on the name of the project, and click on add existing items, and then select what you want to add. It automatically will put the header files under the header file section and the CPP file under the CPP file section. Remember, anything that is added to the source files will take part in compilation. So you've got to be careful. You cannot add everything into the source files because then compiler tries to compile it and it's nothing, a header file is not supposed to get compiled. So if you do this and you click on add, it automatically adds that one over there. And I think we have string copy and string stuff over there, right, in Seneca. So we have string copy and all the good stuff that we have. So I'll use that over here. I'm going to say include CSTR H. And now I can say, I'm going to set an assessment. Actually, I can set an assessment in another way. Instead of setting an assessment, yeah, I'm going to say over here, let's set it in a two different sets I can put. One set over here, I'm going to say cout name. Assessment name. Okay, and for that I need IO stream. Please look how I'm programming. I don't include unless I need it. I just keep writing and I include only when needed. Don't include everything everywhere just in case. That's the worst thing you can do. Now I have cout, then I know I can include IO stream. So I'm going to say over here, include IO stream. And obviously include IO stream. And I can say using namespace std. But I would never include in a header file unless I really have to. Never include in a header file unless you really have to. So that's cout. Now I want to read the assessment name. I'm introducing you to, actually let's do it another way for now. So I'm going to say cin a dot title. I'm receiving the title. Then I'm going to say cout assessment mark. And I'm going to say cin a dot mark. So that is setting the assessment. Okay? Now I want to print it. I'm going to do the same. So definitely it's got to be a constant reference because I don't want it to be changed. You must follow the logic and make it a constant. Now I'm going to say over here cout. I'm just going to print the title. So I'm going to say a.title. And I'm going to open a parentheses and I'm going to put over here a.mark. And go to new line. Okay? So now I have my assessment created. Now what I can do, I can go in main. Remove all the stuff that I don't want. I can include assessment. And using namespace Seneca. Now I can say assessment A, or yeah, A, and I'm going to say set A. Then I'm going to say print A. Okay? This is a kind of a mixture of C and C++. In C, what you did, you passed the pointer. So instead of having an assessment reference, you had a structure assessment pointer A, and then you used the arrow to access the title. And when you were printing it, you passed the address of A and print address of A to print. Because we have a reference, we know that function calls happen like this. So essentially, so let's change this over here. I'm going to call it MA, main assessment. So when the function is actually called over here, we said that the function is called as follows. So it's going to call set assessment reference A equals to MA. So MA becomes a new name for MA, and therefore all the stuff happening in a function will happen to actually to the assessment of main. And running that, we'll do this. So assessment name, I'm going to say quiz 1, mark, 95, and it's going to tell me quiz 1, 95 is the mark. Are we good? Any problem with this? Yes. No. An assessment is an entity of its own. We don't have 5 marks for quiz 1. We have, so what I'm designing over here is an entity. You are thinking, I love the question. You are thinking structured. You have to think object-oriented. When you get your quiz back, how many marks do you have on it? I'm not creating a quiz for 50 students. See, in an object-oriented world, you create an object that represents a quiz, and you forget about everything else. If you want 50 marks, you have to create an array of 50 quizzes. So you can have quiz 1, quiz 2, quiz 3, quiz 4, and each one will have a mark of its own. Now, if you're saying quiz 1 has 50 marks, you know what you're actually thinking? You are thinking we have 50 students, and these 50 students got 50 marks, correct? In your case, in an object-oriented world, you are a structure called student that has an array of quizzes in it, or assessments in it, the number of assessment that is a subject. Like in OOP244, we have 6 assessments. One is midterm, one is yada, yada, yada. So it becomes an array of quizzes inside the student. Then you have to create an array called subject, OOP244NAA, that has an array of students. And each student has many classes. So you build exactly what you see around you. Okay? All right. Again, abstraction, abstraction, abstraction. If I want to write a program that its job is to mark quizzes, then it's going to be a different story. Then you need to create a structure with 1 quiz and an array of marks. Because a program, it's essentially marking. Somebody who's marking has a stack of paper of quiz 1s, and he wants to mark them all. Then your solution becomes what we are saying. But my abstraction is creating an assessment that each person has it, each student has it. I'm looking at it from students' point of view, not from professor's point of view. Okay? Or you can think of it as an element of an array of type transcript. You create a transcript has lots of assessments in it, and each one has its own mark. Follow? Okay. So, now, this is not object-oriented. What I created really is bad. Remember I started the thing and I said, close your eyes, and when you hear hello and nobody, you know where it comes from, it's scary. This is what happens over here. In this thing, this set and print, they have no owners. You don't know who they belong to. This is wrong. This is not a C++ program is written. In a C++ program, what you need to do, you have to teach the assessment how to set itself and how to print itself. You do not pass an assessment to a set of whatever. Assessment has a set function of its own. So, I'm going to save this over here. Actually, I'm going to commit it, then you can see the changes through diffs. So I'm going to come over here inside the OOP244, and I'm just going to commit this one, say commit, and I'm going to click on all, and I'm going to say non-object oriented, non-object oriented assessment. Okay, and I'm going to commit and push it. So when I change it, you can diff it and see what happens, what is the difference between the two. So that's done. Now, I'm going to say in an object-oriented world, a structure knows how to print itself and set itself. And if I do something like this, then there is absolutely no need to pass any reference to here. Why? Because set is part of the structure assessment. Therefore, set has direct access to title and mark. It's part of its thing. It belongs to it. There is no need to pass anything. This is one of the most common mistakes that students make from IPC. When you bring a function inside a structure, it's not a function anymore. It's a member function. Or even better, it's a method. They call it a method. A method or a member function of a structure or a class has access to all its properties. I always give this example and I say, if your nose is itchy, you scratch your nose, not someone else's, because it belongs to you. Everyone knows where my properties are. You follow what I'm saying? It's the same thing over here. So therefore, I do not need to pass anything to here. This const, we have to somehow fix it. So I'm going to put it over here, print. So set and print go inside. Now in here, instead of writing it like that, I'm going to say this is an assessment set. And this is an assessment print. So as you see, now the functions actually belong to a structure. So now the print, obviously, they do not need to receive any type of argument because they already know what the title and mark is and what the title and mark is. Why is it still giving me, anyways. This IntelliSense is a little slow, okay? This is right, there is nothing wrong with it. So I'm saying an assessment has a set that receives the assessment from the console and set its own assessment. Now, if I go back to my main is going to look like this. Instead of passing the object to the set, I'm going to tell, hey, object, set yourself. Object, print yourself. You see that? And obviously, function call is not needed anymore because it's calling its own method. Okay? Having done that, if I run the program now, it works the exact same way. So if I run it, you'll see that nothing has changed. It actually asks for the assessment. Now I can say over here, I don't know, quiz 1. And in here I'll put 95. And it actually prints it the same way that it did for the other one. The difference is that now I can make this one, for example, an array of 3 marks, 3 assessments. And what I can do over here is this. Actually, let me uh, 0, 2. Member. I'm not going to call it member functions anywhere. I'm going to call it methods. Get used to it. Get used to the object-oriented terminology. C++ name is member function. But object-oriented world calls that a method. So call it a method. Because in Python, that's a method. In Smalltalk, that's a method. In C++, that's the method. In Pascal, that's a method. Whatever language you use, when it's object-oriented, it's called a method, okay? So now, what I can do is, for example, create an array of 3 assessments. And I'm going to call it A. It's easier. Now I'm going to write a for loop in here. For integer I set to 0, I less than 3, and I plus plus. C out I plus 1. Like that. Now I'm going to say AI dot set. And after I'm done, I'm just going to do the exact same thing and print them. Now if I run it, it's going to call the set for every individual. So assessment name for the first one is quiz 1, and that's 95. Assessment for 2 is quiz 2, that's 85. And the last one is midterm, and that's 90. And when I hit enter, it shows them all out because the set belongs to the object now, not an exterior thing. Each object called its own set, and that's member functions. Are we okay with this? Are we okay? All right. The next thing we need to do is to protect ourselves from our enemies who do stuff that are not logical. For example, if I write over here M mark is equal to 1, 2, 3, what happens? It means anything that I do will overwrite it. So if I say over here quiz 1, Q1, Q2, Q3, whatever, and whatever. Oh, they're all going to be 1, 2, 3. You're going to tell me, why are you doing that? Why you're just setting it? So don't. The thing is that I shouldn't be able to do it. Print's job is to print something. When you print a piece of paper, the content doesn't change. Printing is not supposed to change. Setting is supposed to change. Remember, we passed a constant assessment reference to make sure it's not changed in the print? We can do that with methods. So in a method, you can actually write over here, print is a const. So you put a const after the name, and you put the same thing over here. What happens? You're actually telling to the compiler, this method is not supposed to change its owner. So you can have variables in there. You can do whatever you want. But if you try to change any of the properties, it won't allow you. So who's your enemy? It's you, the programmer who's writing and does something that is not following the normal logic of a program. We are protecting us from ourselves. That's what it is. So by doing that, you are saying print is not supposed to change anything. You put that on over there. If you, by mistake, try to change something, it's going to tell you, hey, don't. This is constant. So that's not possible anymore. And that's constant. That's number 1. OK? Number 2. What if somebody in here does that? So I'm gonna change this thing over here and say 0, 3 array of objects. And now I'm going to go for a single one because I will give you different examples. So now I'm going to go back to that A thingy. A.set. Oh my God. Entered. Now in here, I'm going to go a.print. We can go to and L. Okay? So what I'm saying is that after I a.set, I do a.set, I can go a.mtitle 0 is X. Okay? So if somebody runs this program, they write over here quiz 1, they write 100, and what they see is X quiz 1. So that shouldn't happen. Remember we talked about privacy, and I say if I ask for a quarter, probably you're going to give it to me. If I ask for $1 to buy coffee, probably you're going to give it to me. But if I actually put my hand in your pocket, then I'm invading your privacy. I'm not supposed to do it. The outcome is the same. I'm going to get $1. But one is invading the privacy, the other one is not. This is invasion of privacy. So how do we enforce it? This is how we do it. You will say these are private and these are public. What does it mean? No one can touch these things. If I had a function in private, only the other functions could call it, nobody from outside. Now if I go back to main, you'll see it won't allow it. And it's going to tell me, yada yada declared over here is not accessible. You're not supposed to touch it. So this becomes private. Now, that brings us, so in here I'm going to say 04 methods and privacy intro. So now we made that actually a private thing. Number 2, in C++, we have something we call a class. It's the exact same thing. If I run it, it works the exact same way. No difference. It works the exact same way. What is the difference then? A class is by default private. You don't need to put a private over there. A structure is by default public. So if you create a structure is essentially a class, but by default, it's public. If you want to, from now on, you're not going to create a structure anymore because you create all the things you're creating are objects. So unless you want to create a record. If you want to create a record of things that doesn't have any methods, then create a structure. It's all public, you can access it. But public and structure, class are the same. Structure and a class are the same. Structure is public by default. If you don't mention anything, it's public. A class is private by default. So we don't need to mention private. Not that it's going to give you an error, but private is by default. So now if I actually uncomment this, although I did not put private over there, it's going to give me an error, of course. It's going to give me an error over here that is not accessible, even if I don't mention it. Are we okay down to this point? Yes? That's it. Nothing else. Nothing else. I thought that they are identical. Like I thought that I can create a structure and start with the private and do everything and then do the public parts, and it's exactly like a class. But later I found out when you go through all aspects of object orientation, if you want to switch it back to a class later, how do I explain? They are the same in a low level. Not a low level is different in computer science. They are the same. The reason is that I'm hesitating to explain exactly what it is that when it comes to matter of virtuality and inheritance and stuff like that, then you have to be cautious about it. I just experienced it as, it was just an experience. For like 20 years, I thought it's the same. And one day I got an error message in my thing, and I'm like, what the heck is going on in here? And I started debugging and debugging and debugging, and I found out that I should have named it, made it a class. So if later on you want to convert a structure to a class, let's say you have a bicycle, and you want to create a motorcycle of the bicycle, and your bicycle is a structure, you cannot create a class motorcycle of the structure. They both must be either a structure or both classes. Because of that, it is always safer to make anything that has action inside a class, and do only structure for records, things that they have no actions inside. Okay? So that's that. All right, now that we have this, we can actually, and methods, like all the other things, are like all the other functions, they can be overloaded. So I can have over here set something like constant character title and integer mark. I can have something like this. And I can go over here and say, for example, str copy into mtitle. I have str copy into mtitle, title, and then I write, what do I write? Title. And then I'm going to write mmark is set to mark. So I am actually overloading it. There's no problem with it. I can do that. So now in my program, instead of actually reading that thing, I can have a.set to midterm test and 85. A.print. So now what I have, the first set is setting it to using console. So I'll go quiz 1. And in here, I'll go 85. And the second one sets it through the program, as you see. It set it to midterm test and print it like that. So you can overload methods too. There is absolutely no problem with it. Are we OK down to this point? All right. Now, the privacy. OK, so one more thing I need to tell you. So C in and C out, they are classes, which means they have methods inside. OK? If I want to get quiz 1 like this, if I write something like this, if I say over here quiz 1, and I hit enter, it goes bananas. Because C in mtitle picks up quiz, and this space it stops at space. This remains in memory. Then the next integer wants to pick up 1, but it can't, and it fails. Okay? There is a function inside C-in that you can actually ask it to get the entire line for you. So I can, instead of, if you know you have spaces inside your name or whatever you are getting, you can always use what we call getLine. That is a method. So you can say cin.getLine. And in that getLine, what you do, you put the string you want to put in there, mtitle, and then you put the count. The count that you put in getLine is the size of the array. You put over here 128. And it guarantees that it's not going to go more than 127 because it knows it's a C string and the array is 128. It knows that's the fact. So doing something like this, instead of writing the extraction operator, now I can actually write something like assessment 1. I can write over here OOP244 midterm test and hit enter, and I put over here 90, and it actually shows the whole thing for me. So I can actually put spaces in it. There are so many things. We're going to go through it in a lab. So go through the notes that we have online. You will see there is the whole lecture about commands about how C in and C out work and how you can format and everything. But that's what we're going to do in the lab. It's not that important at the moment. Okay? The fact that we can actually use getLine is something that is good to know. Okay? So I can actually give you examples that I want. Are we okay down to this point? Okay. So bring the sync up. Assessment with methods. So to see how changes are done and what are the things that you have, you can actually go right-click on the repository and go to Tortoise Git and say show log. When you do show log, it shows what happens over here. So this one, let me just bring it down. See, assessment with methods. If I say assessment with methods, you can just click over here, right-click, and go, or just double-click on it, and it shows what it was and what it is. So at left side, as you see, it shows it was a structure, and the methods was outside. Over here, it's a class, and it has everything inside. So you can see the differences like that. Okay? That's that. Now we're going to go to the next one. Now that I'm creating, so in here I'm going to say, actually this is good. So this is what I'm going to do. Now in here I'm going to say, what if I want to set the assessment to something? Like I want the assessment to have some, as like you can say integer I set to 10, right? I want to be able to do that. I want to be able to set my assessment to something right off the bat, so I don't have to write something. If I want to have some default value, what do? So this is what you can do. There are specific procedures, and I have to tell you this, and I want to put a specific emphasis on it for you to know. That is, there are specific procedures, they are not functions, that you can write inside a class that they automatically will be called when an object is created or when the object is dying. They are not functions. They are procedures. Okay? Let's check. So let's say if I just create an assessment, I want the title to be not set, and I want the mark to be 0. So what you can do is this. Now I want you to pay attention. These special procedures are called constructors. A special procedure carries the name of the class. So, and they don't have a return type because they are not functions. They don't return anything. They are just being called to set up your class when the class is created. So in here I can say assessment and put nothing in here. That means a default constructor or a no argument constructor. So now I can implement that no argument constructor. It's exactly like a method, but as you see, there is no return type. Now I can set it to whatever I want. I can actually call the other function here. I'm going to say set to no title, and I'm going to set the mark to 0. So when assessment is created with nothing, this is what's going to happen. Take a look. First, I'll run it, then I'll walk through it. So as soon as I run it, it says, you see, no title, and it's 0. Right? How did it happen? Let me make it more beautiful so we understand. So it's no title, and the mark is 0. Okay? Now, let's walk through. So when the program is starting to run, when it reaches to assessment, so this is getting printed, so the message is printed over here. Now, as soon as the assessment is about to get created, right then it jumps to the constructor. You see that? So you are not calling the constructor, and you can never call a constructor. Remember that. You are never allowed to call a constructor. That doesn't make sense. Don't do it unless you know what you're doing. But when you do a function call, what happens? The function is called and gets executed and it ends, right? When you do a constructor call manually, something strange happens that you're going to learn later. So do not call a constructor. As you see, it gets, so for example, in set, don't call assessment youth and think it's actually a function. It's not a function. It won't give you an error, but it doesn't do anything. Anyways, so now, as you see, the assessment is called, and it's set to no title, and it comes out, and it's done. Now, let's say I want to create an assessment, and I want to just put a title for it. I want to create an assessment, and I want to just put a title for it. So what do? I can come over here, overload the constructor, and pass over here constant character pointer title. Right? Easy breezy. And then say by default, when you don't mention what it is, it's going to be 100%. So I'm going to say, if that's the case, I'm going to set it to the title that is coming in and 100 over there. You see, I reuse my code. I don't like to rewrite code. That's the wrong thing to do. Because I have the set method over here, why should I rewrite code? It's going to do it for me anyway, right? So I reuse code. So in this, I'm setting it to title and 100. Now, what I can do, so in here, I'm going to call it 04 default or no arg constructor. Constructor. Forget constructor. Okay. Okay. Now I'm going to have a one argument constructor, which means in here now I can say final test. So as soon as the program is running, because it's a one argument constructor, it comes over here, goes to one argument constructor, sets the title to whatever the title that is coming in, and sets it to 100 and comes out. And when it's printing, it's going to be final test mark 100. Are we okay with this? All right. Next. So one argument construct. So in here, I'm going to say 05 one arg constructor as function. I'll explain to you what I mean by that. So take a look at this. I'm going to say integer I, and in here I'm going to put 100. Then I'm going to say cout I. See what happens. 100 is printed. Why? Because one argument constructor is called. When you have assignment at the moment of creation in C++, the line above and the bottom are identical. No difference. So this is same as below. You see that? It's the same. So all one argument constructors can be called in two different ways: function way or initialization way. So remember, this is something extremely important. Initialization is a call to a one argument constructor, which means I can actually say assessment A is equal to final test. And the result will be identical to the other one. When it runs, because it's a one argument constructor, it actually calls the one argument constructor over there. Initialization is a call to a one argument constructor. So you can call a one argument constructor in two different ways, either with parentheses and a value, or you can call it with an assignment. All right? And they actually created new versions for it too. So I'll talk about that later. So 06, this one is going to be one arg constructor. As initialization. Of course, we can have a two argument constructor too with absolutely no problem. So in here I can have something like this and create a title, and I can put a mark. And I simply say over here, set title mark. And it runs the exact same way. So in here, of course, I cannot put an assignment in front of it because it's two values, right? There is a way, actually, I'll show you. So the function call version of it will be final test and say 95. Okay, to call it like that. That's the function call version. If you want, you can use the initialization version, but then you have to initialize it as follows. So I can say assessment B equals to, you put a curly bracket, then you say, for example, midterm test and 85. That is OK. It's like you are initializing a structure, right? So when you do it like that, and that should match the arguments in your constructor, and it works perfectly. All right? Are we good? Any questions down to this point? Suggestions? Class ends at 4:10, right? 4:10. Anybody wants a break? Like a 5-minute break? Yes, so really 5 minutes. I'm going to start exactly at 3:40. Okay, 5 minutes break. Let's continue. Now, we know the construction. How about destruction? We know when it gets created, I can actually tap into the creation of the object and do something right after the object is created. So again, remember, when does this question is like this is a quiz question that you're going to receive. When will a constructor be called? Before the object is created? After the object is created? So right after the object is created is the answer. So first the object gets created, and then immediately the constructor is called to do whatever is needed inside. Okay? Remember that. Now, what is a destructor? Destructor is the function, is a procedure again, that is called right before the object is about to die. Okay? So how does it work? The syntax of a destructor, because destructor doesn't receive any argument, it doesn't make sense. You don't want to give anything to a class while it's being dead. You just want to do something when it's dead. Okay? So for the assessment, for the destructor, what you do, you start it like this. You put a tilde, then you say assessment, and that becomes the destructor. Okay? So this essentially means I want these things to happen before the object dies. We don't need to do anything now because this object has all its data inside of itself. The assessment is a title as a character of 128 things in it. So when the assessment dies, the array goes with it. I have nothing to do in here. I'm just going to write some message over there so we can see when it's being called. So there's no need for the destructor. We are just doing it to learn. Okay? So in here, I'm going to say cout. I'm going to say the following assessment is about to die. And I'll go to new line, and I'm going to print it. And as you see, I don't need to mention a.print, just going to say print. So it's going to print. So now if I run it, you will see when it's being done, if it's when and how it's going to die. So if I run the program, you will see I created two objects in here. Take a look. I created object A that had final test, B that had midterm test. As you see, the midterm test is dying first and then final. Remember, when objects are created, they die in reverse order, always. So the one that is created last will be dying first. It's always reverse. Okay? Remember that. This is extremely important to know. And the good thing about this thing is that you can actually trace. So create a destructor and put stuff in there, and you'll see when things are getting created and destroyed. And it's a very actually interesting thing to know. Like sometimes we really don't know if objects are getting created or not, which is another story. When we come to it, we're going to have a session over when the objects are getting destroyed and when it's going to get created. So we're going to go through it. Now, to make sense of this constructor and destructor, I am going to convert this assessment to a dynamic one. So I'm not going to say that assessment has 128. I'm going to make that dynamic, which means any size they put, it's going to readjust it by that. To do that, I created a completely separate project over here, dynamic assessment, I call it. So first I'll save everything. Then I'm going to right-click over here. First, I'm going to set it as startup project. So that runs when I'm compiling first. Then I'm going to say add existing item. I am going to go to the other one, copy the assessment, HCPP and PRG, copy it. I'm not just going to add it. I'm going to copy it and bring it to this project and paste it here. Paste, and then add it. Okay, so The ones that I have, if I change this assessment, the other one's not going to change. Now, I'm going to leave that private be. I like to see the private over there. So this will be a dynamic one. Okay? Very first thing that I'm going to do is default constructor. So in default constructor, I put no title in there, right? Now what I'm going to do is what we call safe empty state. What is a safe empty state? When you have an object that has iffy stuff in it, and you want to recognize if the object is empty or not, then you can set it in an empty state. The best flag for an empty state is a null pointer. So I'm going to go, let me just separate it into two again. Oh, and I need cstr.h and give me a second. Add existing items. I need the cstr and copy, paste. Because it needs those two too. Okay, anyways, now I'm going to split it in two. Close that. Split it in two. And bring up assessment.cpp. So in here, instead of setting it to no title, I'm going to actually say mTitle is set to null PTR. So now, when an assessment is created by default, it's literally empty. And I'm going to say mMark is set to 0. Now, what I can do in print, what I can do is this. I can actually write an if statement. I can say if is empty, then right over here, cout, assessment is empty. If not, then print the content. So what this is empty is not a function, right? Who cares? I'll create a function. So I'm going to come over here and create a Boolean is empty. Is empty. I'm going to make it a constant because it's not going to change anything. It's just telling me if it's empty or not. I'm not going to make it as a function that can change. And in here, I'm going to say return mTitle being equal to null PTR. So if mTitle is equal to null PTR, the result of this operation is true. So it's going to return throughout. If this is not null, then it's going to be false, which means I know I have something in it. So now my function over it, my print over here will print an empty assessment properly. Okay? Number 2. What do I do? Next. So how to set the assessment? To set the assessment, what I need to do, first of all, we know that when a title is created, it's null, right? That's what we did in this assessment. Now, let's do it for one argument constructor over here. So I'm going to go to one argument constructor. I can go do the set first and recall the first over and over. Okay? So set would be intelligent enough to do everything dynamically. But I'm going to do it for the first one, just for you to see how it's done manually. Then we're going to go do the set. So if I want to check this, what do I need to do? First of all, remember, because it's a constructor, the object is being created. An unused pointer should have what in it? Null. An unused pointer must be always null. So before I do anything, I'm going to say mTitle is set to null PTR. So now I'm clear. I followed the standards of dynamic memory allocation. Now, I want to set the title to the title that is coming in, right? How do I know that title is actually does actually have something? Maybe that's null. Maybe it's not pointing to anything. So I need to check, make sure that that title actually has something in it for me to copy. So I will do that. I'm going to say if title is not equal to null PTR. If not empty, then allocate and copy. Right? If it's not empty, I'm going to allocate and copy. So how do I allocate and copy? First, I have to allocate memory. Title, I don't need to delete anything. Why? It's a constructor. It's just got created. I'm 100% sure there is nothing in it. So I don't need to worry about it. I don't need to wipe anything out. It is null, and it's a constructor. I have nothing in it. So I'm going to say it's equal to new character. How many characters do I want? Exactly to the size of title. So I'm going to say strlen of title. But I know I need to add 1 for null termination. So I'm going to say +1. This is the most common mistake in memory management problem in students. You allocate memory for a string, you forgot to add 1 for null. So now mtitle has enough, not only enough, exact amount of memory it needs to hold the title. Now I can say strcopy, and I don't need to check to see if the size is big or small. Whatever the size was, I have the perfect size for it. So I'm going to say copy into mtitle the title. And I'm done. So now the assessment is dynamically allocated. For the 2 over here, what do I do? For the 2 over here, what do I do? I already wrote the code in here, right? So I'm just going to call that constructor, say assessment title. Then in here, I'm going to say mark, mark is equal to mark. Correct? Are we okay? No, we are not. I told you you cannot call a constructor, didn't I? I got you, didn't I? I told you constructors are not functions. You can't call them. When you call a constructor, it does something strange that you don't yet understand. Nothing's going to happen in here. If I compile and run it, you're not going to give in again an error. But you will see that nothing is set. Do not call a constructor. Do we understand this? OK, thank you. So now that I have done this, I'm going to go and do the set so I can recall the set over and over and don't have to do this 50 times. OK? So now I'm going to come to set here. So because set can be called at any moment or time, it means title of the assessment might already have something, right? If that's the case, again, rules of dynamic memory allocation. Before doing dynamic memory allocation, you delete the title. You don't care if it's null or not. If it's null, nothing's going to happen. If it's not null, the memory is gone. Now you can do whatever you want to do with it. Then what do? You do exactly what we have done in here. OK? All right. So I delete the title. Remember I told you whenever you delete, set it to null? I don't need to because I know immediately after I'm setting it, right? But this has a bug. What is the bug? The bug is that I didn't check to see if the title has something or not. So if I run it, it will work for a time. But one time it's going to fail on you. So it's a good idea to do an if statement and say mtitle. If mtitle, you don't need to say not equal to null. I did it in the other one because it was a rookie way of doing it. But when you do it like this, you don't actually need to. Because if it's null, it's false. If it's not null, C consider non-zero values as true. So this is the same as same as M title not equal to null PTR. And now that I have this if statement, it is possible that dynamic memory allocation might not happen if the title is null. Now I have to actually set the M title to null PTR to make sure that if the if statement doesn't happen, M title is in a safe empty state. And now I have my set. So my set receives the title and a mark and sets everything, right? Now I can go back and reuse the code everywhere I want. All I need to do is to make sure that I follow the rules of dynamic memory allocation. So I'm going to actually comment this one. So instead of that, I can actually say set title and 100. We said when we create it, it's going to be 100, right? And for the other one, I'm going to say, first, I have to set the M title to null. That's the rule of construction. Any unused stuff has to be set to null. Now I'm going to say set title and mark. And now that I have the dynamic memory allocation done, this is the place that destructors become the most important thing. Why? Because now in the destructor I can say delete M title. Therefore, the class itself will take care of its own memory. When the dynamic class is created, it allocates it. At the moment of deletion, whenever the thing is going to die, it's going to call the destructor. So it's going to get deleted. And now I have a perfect class created over here. I have two classes, so I'm going to just start it and walk through it, and we'll see exactly how it's going to happen. Actually, you know what? Stop. I'm going to make this one like this. So I call two different constructors. There we go. OK? And I'm going to have a C2, assessment C. And in here, I'm going to say C.print. So I have three different ones, right? I'll start. Put this one at left, this one at right. Back in the can you see this? The font is big enough? All right. So I start, and I come in. And now take a look at A. A, all garbage. You see that? All garbage. B, all garbage. C, all garbage. Now, I'll go to the constructor. One argument constructor. The one argument constructor is called. It calls the set wait a minute. Did I change the wrong version? Oops, I changed the wrong version. I have to go back and bring the other ones in. This is the previous one. I don't have any of those dynamic stuff over here. Give me a second. Give me a second. Excuse me. I made a boo-boo. Stop. Shoot. You know what happened? I changed the previous project set. So let me quickly go to assessment.cpp, Control A, copy, and open here, assessment.cpp. That's Control A, Control V, and save and close. So that is done, and this is done. Now I'm going to go, wow, I have two programs. I don't know which one is one. But we'll find out. So I'm going to copy this. OK. I'm going to copy this. And I'm going to open this one and see which one it is. Oh, I have that one as right. So the good thing about Git is this. Take a look. So now my assessment is the dynamic one over here, right? And I have, what is it? Must be a modifiable value. What's going on here? What's going on here? Just let me close and open and make sure everything's good. So this is the assessment. And I have set and everything done. This is this one. Let me compile it. Rebuild. What did I do? Oh, the assessment is not changed. This is supposed to be a pointer. Okay, sorry. And I don't have is empty, so I'm going to add is empty over here. Bool is empty and const. Recompile. Well, good, but before I do anything, because I know I'm going to forget, I'm going to go in here, right-click, open in a file folder. So I'm going to go in here. I'm going to click on this one, and I'm going to right-click, and I'm going to say, actually, I'm going to set it later. Forget it. I'm not going to revert it now. So I'm going to set the values back to what they were before, but not now. And let's run this. So I'm going to run this. Rebuild. We're good. Let's actually see what happens. Control F10. There we go. Left, right, and let's do it one more time. So the assessment is going to get created. It goes to one argument constructor, sets the title to null. Because it's a constructor, it's an unused pointer. It has to be null. It comes to set. It sets, it says delete title. It's null, we don't care. Sets it to null, we don't care. Is if, it shouldn't be m title, it should be title. I am checking the title, not m title. So if title, it means I have something over here. So it gets the length of the title, allocates memory. Now it has some piece, and it can get copy into it. Now m title will have the value, and mark will be set to 100, and it goes out. When it goes to two argument constructor, it comes exactly like the other one. Set it to null. Set is called. We did it. No need to walk through it again. It does the exact same thing and sets it to midterm test. And the last one is the one that sets it to null pointer. Now it comes to null and comes out. A gets printed. It is not empty. It comes over here, prints the final test. B gets printed. It is not empty. It prints the midterm. C comes over here, and because it's empty, it's going to say assessment is empty. Let me come to it one more time. Run to this point. F5. So C, it goes to C. Because it is empty, returns true, and it says assessment is empty. So the print is working in a safe empty state too. And we have ourselves a dynamic class with methods, constructors, and all the good stuff that we have. We good down to this point? Are we okay? All right, that's it. Have yourself a beautiful day, and I'm going to fix the ones that I made a boo-boo in back to what it was before, and then we'll continue. Have a good day.